Hello folks, we are back with the part 1 video of this exercise 5.3, and every exercise we've been seeing throughout that we have been taking some new concept. Like for example, in the first exercise we took continuity. Now in this exercise point 2 exercise we took differentiability, and we looked at the various aspects of differentiability. Now throughout the chapter we will be taking up differentiability only, but then different concepts of differentiability. So here now this is called as implicit functions. Now what is implicit function means, in the previous case we were given some function of x, and for our convenience we called it as y equal to that particular function, and we took the differential, we got dy by dx. That's how we were doing. Now in this case it's not like that. You don't have an exclusive function, something given like that only in terms of x. Yeah, you remember in the earlier exercise, only in terms of x, there wouldn't be other things coming. It may be complicated functions, but it will be only in terms of x. Here it's not like that. Here we have a particular statement or an equation with y and x both mixed. These kind of functions is called as implicit function. What we did earlier, that's explicit, where we had only x. Here it is implicit, where it is mixed. So you have y and x mixed like that. So if at all it is mixed, then how we'll find the derivative? So that's what we are going to take up in this exercise throughout. We will be having this x and y mixed like that, and we have to find the derivatives. So that we are going to start. We know, I hope we know all the formulae. Once we know the formula, we have to just substitute. Only 2-3 words of caution that we have to keep in mind while we are doing the derivatives. That's all. So let's start right away. We have to get the derivative dy by dx. Question given to us is 2x plus 3y equal to sin x. We should get dy by dx. That is our work. So what we will do, taking derivatives on both sides. So we are taking to begin with, because we are beginners, in the first 2-3 steps I will show you all this. Later on we'll get used to and we'll get the derivatives directly. So we are taking the derivatives on both sides. After all, derivative is also an operation, so we are performing this operation on both sides, finding the derivatives on both sides. And we know by algebra of derivatives that they u plus v whole derivative is u derivative plus v derivative. We learned yesterday in the table. So this is the derivative of, it is the derivative of 2x plus the derivative. Now this only in the first problem also I will be writing it so explicitly. Later on we assume and we take steps little directly, because it's not much required from exam point of view. We have to learn to be a little more brisk between the steps. So this is what we have done. We have taken the derivatives on both sides, then we have distributed the derivative. Now we will take individual derivatives. We also know that if there is a constant, that does move out of the derivative, like our limit. So it is like 2 d by dx of x and 3 dy by dx and derivative of sin x. So let's do it right away. Common sense, dx by dx is always 1. So this is just 2 left. This is 3 dy by dx, nothing to do there. And derivative of sin x we know is cos x, right? Our idea is to get dy by dx. So we have to push the other terms on the other side. This is cos x minus 2. 3 is there over here. So like that, dy by dx becomes cos x minus 2 by 3. So that is the derivative. Yeah, so that's how we go about doing it. When we have implicit functions, we will have to take this kind of logic, and this is how we're going to do it. Next question is also like that, but except for that sin x, it is becoming sin y. So because we are beginners, let's take the derivative on both sides. D by dx, mind you, of a y function. D by dx of yeah, we'll come to it. I think I will not confuse you right now. So what will happen here? It is like 2 times d by dx of x. Yeah, why? Because it distributes to this and to this, and this is 3 times dy by dx. One step I have skipped from there, okay, because we are gathering momentum. And this is d of sin y by dx. Okay, this we know is 1, and this we know nothing to do, dy by dx. Now this is a place where we have to employ your head. Sin y, when you take the derivative with respect to y, yeah, sin y with respect to y is cos y, but this is with respect to x. So sin y is cos y. We will write the derivative first with respect to y, and then because this is with respect to x, we have to write dy by dx. You can reason it by taking u as sin y and then taking du by dy and then dy by dx. That's how you get du by dx. That way you can reason it. And for the time being, we'll make ourselves understand that when some function, any function is in terms of y, we are not going to always apply chain rule and all. It's going to take time. So that is why what we will do is any function which is in terms of y, because we are taking the derivative in terms of x, we will write the derivative of that function with respect to y, but just write an additional dy by dx, okay, along with that function. Then this comes because of the chain rule, but now because we're quite matured and we've done so many problems, we take it right away. That always now you may have a function which is having z or it is having w or whatever. So no matter how many functions are there, only the function with respect to x will not have, it also has dx by dx, but that becomes 1. We will not write like this, but any other function which is other than x will get this extension. We have to have this term, then only we can account it by chain rule, right? So that's how we are going to understand. So now what happens, because our intention is to get dy by dx, so let's bring this dy by dx there. So you are getting 2 equal to cos y dy by dx minus 3 dy by dx. As a result, you have your dy by dx common. What is left here? Cos y minus 3. This is 2. So finally your dy by dx will become 2 by, because it's a product here, cos y minus 3. Yeah. That's about it. Next also, let's start with the derivative directly. We're taking the derivatives on both sides with respect to x. D by dx of ax plus by squared and d by dx of cos y. So it is a times dx by dx plus b times d of y squared by dx and d by dx of cos y. Let's find the derivatives. A dx by dx we all know is 1. Now it is a y function with respect to x derivative. So first let's find the derivative of y squared with respect to y. Then we have to account for the y, right? So what is the derivative of y squared with respect to y? We know any polynomial which is of the type x raised to n has got the derivative nx raised to n minus 1. So like that, y squared will have the derivative 2y, right? So y squared has got the derivative 2y with respect to y, not with respect to x. So if it has to be with respect to x, you have to have dy by dx, right? With respect to the same variable, it has got dy, but here they have asked with respect to x, so you have to account for it. Now again, cos y, we'll first find the derivative of cos y with respect to y and then account for the variable x. So cos y we know is minus sin y, but that is with respect to y, not with respect to x. So to get it with respect to x, it is dy by dx. So let's see now this a minus sin y dy by dx and minus 2by dy by dx. So what will you have? Dy by dx times minus 2by minus sin y, and here it is a. So what is your dy by dx? Dy by dx is a by minus 2by minus sin y, or in other words, you can have them a coming up, minus a times 2by plus sin y. That is our dy by dx. Fair enough. Let's as soon as that is over, let's take the next problem again. Xy plus y squared is tan x plus y. We'll take d by dx on both sides, so derivative on both sides. So d by dx, it's not going to be an easy affair because it looks quite complicated. D by dx of tan x plus y. Okay, so this is d by dx of xy, then d by dx of y squared, then d by dx of tan x and d by dx of y. Okay, now to start with, there's a product term. right? And we have learned how to find the u into v derivative is u derivative into v plus v derivative into u. So we'll consider this as a product. First, x as it is, derivative of y as it is, derivative of x. We are treating it as a product. Now this is derivative of y squared with respect to x. First the derivative of y squared, then that with respect to x. Derivative of y squared with respect to y. So derivative of y squared with respect to y is 2y. We have learned in the previous problem. And because it is with respect to y, we are accounting. Then on the right hand side, it is derivative of tan x with respect to x. Thank God. So you only have to find the derivative of tan x. It is sec squared x. So that is sec squared x. Then dy by dx, nothing to tell much. It is just dy by dx. Okay. Now what all things can we do here? It is x times dy by dx plus y times dx by dx is 1 plus 2y times dy by dx is equal to sec squared x plus dy by dx. So let's have the dy by dx is on one side. So you will have y minus sec squared x. We're bringing the sec squared x to this side. Dy by dx is already there here. Minus x dy by dx and minus 2y dy by dx. So let's take the dy by dx common. You have 1 minus x minus 2y, and this is y minus sec squared x. So your dy by dx will become y minus sec squared x by 1 minus x minus 2y. Yeah, so that is our dy by dx. And that's all about this video. More problems are there. We'll meet in the next video. Thank you.